This lecture is about the cochlea. So, hearing takes place in the cochlea. And this organ is a spiral, sort of snail-shaped organ. So, this kind of a thing. And there are 2.5 turns in the spiral. But unwound, it looks like this. So you have the stapes. I hope you remember the stapes. That's not part of the cochlea, that's a part of the middle ear. And then we have the oval window. So here's the stapes. Here's the oval window. And then we have this long tube of a thing. Remember, this is the unwound cochlea. So, roughly like that. More or less all equal sizes. There we go. So there we are. And then at the far end of this drawn out tube, I'm going to do it like this just to differentiate it. Here, this is the round window. So again, the middle ear is on the other side here, and we have this area in here. I'll do this. I'll do it like this. That's the window. That's the round window. So like that. There we are. Okay, so we have the oval window. So then this tube up here, this is the scala vestibuli. And this contains perilymph. And this here then is the vestibular membrane. So that's that. Then down here, this other open area then, this is the scala tympani, which also contains perilymph. This is the cochlear duct. So this is actually kind of a different place here, also sometimes known as the scala media. This, meanwhile, contains endolymph. So we have a different fluid in here. This membrane here is a very important membrane. This membrane here is the basilar membrane. And you can see that that is the bottom of the cochlear duct. That's an important thing to remember. So there is the bottom of the cochlear duct. And then this area here at the very end, then, this is known as the helicotrema. Basically, the final end of this peculiar organization of tubes, and it would be that final little point in the middle of a spiral there. As these tubes get all wound around into a spiral, the helicotrema is that smallest bit in the very middle. So when the stapes oscillates back and forth, you remember the stapes. This is the toilet plunger here that is pushing against the oval window. So when it oscillates back and forth against the oval window, it sets the perilymph Remember, this is full of perilymph here. Here's the scala vestibuli there. So it sets the perilymph in the scala vestibuli in a similar back and forth motion. So it sets up waves of pressure in this fluid. So as I said, when you have the fluid going back and forth like this, when this happens, the pressure waves depress the vestibular membrane. I need to write a little bit more here about this because this all goes together. This sets up pressure waves, and these then depress the vestibular membrane. Let's do this. And the basilar membrane. So this and this. Here's the vestibular membrane here. Here is the basilar membrane here. And so what I'm saying here is that as the fluid winds up going in pressure waves, this is going to depress this membrane here, and it is going to depress this membrane here as well. And this is very important because depending upon the frequency of these pressure waves, you're going to get the maximal amount of depression in different places. So here's where it starts turning into hearing. High-pitched sounds then create pressure waves of a higher frequency. So far, that's pretty easy. And these high frequency sounds push down these membranes very near to the oval and round windows. So basically, if you have high frequency sound here, you're going to get these two membranes then doing a lot of vibrating right in here. So this, near the oval and round windows then, I'm just going to say this is the basal part of the cochlear duct, so near the base here. So that is to say, basically, I'll just say the near end of the cochlea. So the thing to really keep in mind here is this. The basilar membrane oscillates in time the pressure waves. And as we have said, the higher sounds wind up having the basilar membrane vibrating there. Meanwhile, lower sounds create maximum vibrations further down the cochlea. So remember, low sounds wind up setting up vibrations here nearest to the middle ear. Then as you get lower sounds, high-pitched sounds vibrate here. As you get lower, they move further along, like this. And the lowest audible sounds create maximum vibrations near the end of the cochlea. So in that area that I labeled the helicotrema. So basically, you have the vibrations in the air that came from the pinna through the external auditory canal, through the ossicles in the middle ear, and then here's the last ossicle, and now it is being transferred to fluid vibrations along here, and the fluid vibrations carry on and make these membranes vibrate. And then eventually, you may recall, this is where those vibrations finally die out, basically by having the round window oscillate. That's what dampens everything so that you can get new sounds coming in. And what it really comes down to then is that you have the lower sounds that set up the maximum vibrations in these membranes down at this end. The lowest sounds will be here. Anything lower than that, you just basically don't have the equipment for it. And then you have the somewhat higher sounds here in the middle, and then the highest sounds that we can hear will set the membranes in this area vibrating. And so that then is how the vibrations from the atmosphere wind up being translated into the cochlea.